Have you ever noticed that with CWDM transceivers and multiplexers, sometimes you have even numbers and sometimes odd numbers describing the individual channels? So in other words, sometimes you've got 1310 and sometimes you've got 1311. If you're interested in finding out why that is, and more importantly, if they are compatible, stay tuned. One of the main drivers behind the development of CWDM actually was to find a more cost-effective optical multiplexing solution compared to DWDM. Now the solution actually then came with specifying a broader channel spacing. So in other words, compared to the roughly 0.8 nanometers of channel spacing for DWDM, CWDM was specified with 20 nanometers of spacing. Now this extra spacing actually brought a great advantage because the tolerances for the filter technology as well as the transceivers was much broader. And especially for those transceivers, what that actually meant was that it was possible to use uncooled lasers, which was the case for DWDM. And that actually brings us to the topic as to why there are sometimes the odd and sometimes the even numbers. Let me explain. As I mentioned before, lasers used in DWDM transceivers are actively cooled, and that is for a good reason, because the wavelength emitted by a laser actually drifts depending on the temperature. So if we have a look at this graphic here, the green actually represents the filter, and you've got the typical roll-on and roll-off characteristic, and then this part here in the middle is the so-called passband, and that's where the laser needs to fit through. Now we've got the theoretical center wavelength, but if that laser then drifts depending on the temperature to the left or to the right, that means that it can actually drift out of that window. So let's get to the actual topic of this video. In other words, why do we sometimes have those even numbers and sometimes the odd numbers to describe the CWDM channels? In order to do that, we actually need to have a look at the temperature range that is used to specify products that are predominantly used in data center applications. And as you can see here, that temperature range actually goes from 0 degrees Celsius to 70 degrees Celsius. Now in the original CWDM specification from 2002, what happened was actually the center wavelength of the individual lasers of those channels was measured at room temperature, and the result was these even numbers. But it quickly became clear that it actually made more sense to measure the wavelengths in the middle of the complete temperature range, so in other words at 35 degrees Celsius. And as I mentioned before, based on temperature, the center wavelength actually drifts. And that also happened here because that drift from, or that shift from room temperature to 35 degrees actually resulted in those odd numbers. So that is the reason why we sometimes have the even numbers and sometimes the odd numbers to describe the CWDM channels. Now the big question is, of course, are they compatible? And the answer is yes. That revision out from 2003, so over 20 years ago, is still the revision that is active. So in other words, all the equipment that has been around for more than 20 years definitely is all following that same standard. And well, why do we still see the even numbers sometimes? Maybe it's easier to remember, maybe it looks nicer, I don't know. But the point is, it basically describes the same thing. So I hope you learned something today and you enjoyed this video. If so, please leave a comment and see you soon.